B.Sc 5th semester, first chapter vector spaces, internal composition. Let A be a set, and if A comma B are two elements belongs to A, then their operation is also belongs to in the same set. Here A star B is unique, then star is called internal composition. That is a binary operation on A is called internal composition in A. Next, external composition. Let V and F be two sets. If A belongs to F, alpha belongs to V, then A circle alpha belongs to V. A circle alpha is unique, then circle is called external composition. Vectors. Let V be a non-empty set whose elements will be called vectors. Elements in V are called vectors. Scalars. Let F plus dot be a field, then the elements of F will be called scalars. Space definition. Let V be a non-empty set and F be a field under addition and multiplication, then V is said to be a vector space over the field F. If this is an abelian group, means it satisfies 5 properties: closure, associative, identity, inverse and commutative property. Next, scalar multiplication, that is alpha belongs to V, A belongs to F, that implies A into alpha belongs to V. Next, A into alpha plus beta equal to A alpha plus A beta for all A belongs to F, alpha comma beta belongs to V. A plus B into alpha equal to A alpha plus B alpha, A comma B belongs to F, alpha belongs to V. And AB into alpha equal to A into B alpha for all A comma B belongs to F, alpha belongs to V. 1 into alpha equal to alpha for all alpha belongs to V, 1 belongs to F. Second note point, if F equal to R, then V of R is called a real vector space. If F equal to complex numbers, then V of C is called a complex vector space. If F equal to Q, then V of Q is called a rational vector space. Fifth point, R of R, C of C, Q of Q, R of Q, complex numbers over real numbers, complex numbers over rational numbers, all are vector spaces. Next, sixth point, R of complex numbers and integer set over Q, rational numbers over R, not a vector spaces. Observe here, we want a condition in V of F, always F is subset V. But here, complex numbers does not subset R. Complex number set is the biggest set other than real numbers. So, now example, we consider Z of Q is not a vector space. Example, Z of Q is not a vector space. So then Z of Q means V of F. So conditions for vector space. First one, Z plus V plus is an abelian group. So in V we have Z. So Z plus is an abelian group. Already we know. Next, scalar multiplication. We consider alpha belongs to V. So 5 belongs to Z. Next, A belongs to F. So 2 by 3 belongs to Q. A into alpha, 5 into 2 by 3, that is equal to 10 by 3. 10 by 3 is does not belongs to Z. So why? Because here Z is integer set. Integers numbers is not in the form of P by Q. So that's why it is does not belongs to Z. So scalar multiplication is not satisfied. Therefore Z of Q is not a vector space.